Welcome back to the deep dive. If you're gearing up for the Agentforce Specialist Certification exam, you know this one's different.
Oh, absolutely.
This isn't about the high-level buzzwords. You really have to get into the architectural DNA of Salesforce's generative AI.
It's all about dependencies, constraints, and the exact sequence of operations. This is not a marketing presentation.
Oh.
Our mission today is, well, it's laser-focused. We want to be your study partner. We are going to turn this entire architecture into a technical blueprint for success on that exam.
Okay.
We're cutting through all the strategic noise to pull out the exact technical constraints, the dependencies, and those critical sequential processes that you have to master to get a high score.
So this is the knowledge you need to actually deploy an agent reliably, not just, talk about one in a meeting.
Exactly.
So our sources for this, all the technical docs, the exam guides, the videos, they all point to 5 core pillars. And their weighting is, well, it's crucial. We're talking agent architecture and structured memory first. Then the huge one, prompt engineering, which is what, 30%?
A massive 30%.
Right. Then there's the 20% foundation of data cloud and grounding, the strict discipline of deployment and metadata, and finally security, the trust layer, and API integration.
And so important to remember the context here. We're dealing with customized AI agents. These things are built to reason, to perform complex, actual business actions.
Right, inside the CRM.
And to operate with enterprise-grade reliability.
Mm-hmm.
These are not just simple chatbots spitting out knowledge articles. They are transactional participants in your actual business processes.
Okay, so let's unpack this right from the very beginning, right at the foundation. Before we can even think about a prompt or a variable, we have to understand what makes these agents. Well, what makes them tick? What's the anatomy here?
So we start with the absolute foundation, which really emphasizes a separation of concerns. The number one problem we have with any modern generative AI is that an agent can't rely purely on the large language model's power alone.
Because that power is just chaotic.
It's chaotic, it's flexible, and it is absolutely non-deterministic.
Mm-hmm.
For enterprise use case, think about changing a shipping address or approving a loan.
Mm-hmm.
You need structure. You need governance. You need predictability.
The structure is the harness.
Okay.
It's what turns that creative chaos into something reliable you can actually use for automation.
It is.
Mm-hmm.
And to do that, the agents have what we call 4 core agentic capabilities. You should think of these as the foundational pillars of their whole operational toolkit.
Okay, so what are they?
Reasoning, doing, knowing, and remembering.
All right, let's start with reasoning.
Reasoning is where the agent, really earns its keep. This is its internal planning engine. It autonomously looks at a multi-step user request, like, say, I need to dispute a charge on my old credit card, and then, also update my mailing address.
A complex 2-part problem.
Exactly. And the reasoning engine figures out the sequence of steps, which topics to trigger, and which specific deterministic actions to call to solve that problem. It's the cognitive part that turns a vague user intent into an executable Salesforce process.
So reasoning is the blueprinting phase. Once that blueprint is laid out, the agent moves into the second pillar, which is doing. This is where, the rubber meets the road.
Doing is the execution phase. The agent shifts from that internal planning to becoming a transactional participant. This is where it actually performs actions that have a real governed impact.
Like updating a record.
Like updating a critical Salesforce record, kicking off a complex flow that has to run validation rules, or initiating a payment through an external API. It's the active part, and it's always governed by the platform's security layers.
Okay, so that's planning in action. The third pillar is knowing. This feels like it's all about data quality. How does the agent know what information is true and what isn't?
Knowing is its data discernment capability. And this is all powered by Retrieval Augmented Generation, or RG. It grounds the agent's response in verified corporate data.
It stops it from just making stuff up?
It stops the LLM from hallucinating answers based on its general, scrape the whole internet training data. When an agent uses RG, it's essentially asking, what do my internal verified company knowledge articles say about this? Not, what does the internet think about this?
So that ensures the knowledge is coming from your controlled, trusted sources.
Precisely.
Okay, so RG gives us the ability to know. Now, the final pillar, remembering, is actually defined by, well, a massive inherent limitation in the LLM architecture itself. And this limitation is the whole reason we have the control structures we're about to get into.
You've hit it exactly. All LLMs have an inherent weakness. Very limited short-term memory. It's called the context window. They really struggle to reliably hold on to specific details or conversational history across multiple turns.
So if I gave it my order ID 5 minutes ago, I might have already forgotten it.
It might have completely forgotten it.
Yeah.
That standard LLM conversation is, by design, essentially stateless. And this lack of reliable, persistent memory is the direct architectural motivation for implementing what we call structured memory. And we manage that through variables.
Ah, okay. So that brings us to the solution. Variables. These are the scaffolding we build to stabilize the agent's memory. Why the emphasis on structured memory?
The structure gives you persistence and, most importantly, security. Variables are secure containers. They hold stable values, text, Boolean, a number that cannot be accidentally altered, reasoned away, or hallucinated by the LLM itself.
So it's a safe box for data.
It's a safe box. When an agent uses a variable, it's bypassing the LLM's unreliable short-term memory. And that leads to dramatically higher reliability, or what the documentation calls deterministic outcomes.
And this deterministic state is crucial not just for one agent, but for a whole ecosystem of agents, right? For orchestrating multiple bots handing off tasks.
Exactly. Variables provide that shared, consistent understanding of the process state that you need for a smooth handover. Imagine one agent verifies a user's identity and stores his verified true in a custom variable.
Okay.
That variable becomes the secure token that allows a second, specialized payment processing agent to proceed. They coordinate perfectly because they share a guaranteed memory structure that is completely independent of the conversational text.
Okay, so for the exam, you have to know the two types of variables inside and out. Let's start with context variables.
Context variables are strictly system-generated. They're sourced automatically from fields on the underlying Salesforce messaging session object. That's the record tracking the conversation. This includes any custom fields you've added.
And the critical constraint here, the one you can't forget.
It is non-negotiable. Context variables are strictly read-only. The agent cannot change them. They provide background info like the user's language, but the agent can't alter it mid-session.
And the syntax is the dead giveaway.
It is. They always use the prefix, context.variable AP name. If you see that context.prefix, you know immediately it's read-only, it's system-generated, and it's coming from the session record.
Okay, now let's contrast that with the second type. Custom variables. These are the ones the agent is actually building and using during the conversation.
Right. Custom variables, or sometimes you'll see them called conversation variables, are unique to the current session. They hold text, Boolean, or number values. Now, here's the absolute critical constraint. This is a high probability exam question.
Okay, I'm ready.
Custom variables must be instantiated only via action output.
Wait, let me push back on that because that sounds like a lot of work. If the user types, my new address is 123 Main Street, you're saying the agent can't just extract that text and put it into a custom variable called new address?
That is the core architectural principle. You are 100% correct. It cannot.
It has to run a flow first.
It has to. If the user types, my account number is 12345, the agent can reason about it, but it cannot put that value directly into a variable. And the why is fundamental to security and trust. This constraint guarantees that the variable's value, especially for something critical like is verified, originates from a secure, deterministic process running exclusively on the Salesforce platform.
A flow, an Apex action, an API callout.
One of those three. It prevents the generative, chaotic side of the AI from corrupting the rigid, necessary structure of the agent's secure memory.
I get it now. So the LLM handles the chat, but the platform handles populating the secure data. It's a separation of duties.
That's the model. And their syntax is simpler, which reinforces this. Custom variables have no prefix. It's just the API name, like client account ID.
So what powerful capabilities does this unlock? You mentioned two big architectural advantages.
Number one is what we call persistent dynamic grounding, or, just context retention. By storing critical facts persistently outside of the LLM's leaky short-term memory, variables create a guaranteed long-term memory to the whole session.
Solving that inherent weakness.
It solves it. And number two is execution control, or determinism. This is about making the agent predictable when the stakes are high.
Right.
Variables act as gatekeepers. They enforce these predictable flows. The agent might want to transfer funds, but a control filter, which we'll get to next, will block that action unless the custom variable MFA complete is set to true by a successful authentication flow.
Okay, let's make this practical. Walk us through the action cycle. This three-step data flow that uses variables to get these, massive efficiency gains.
Right. The action cycle makes the LLM's job so much simpler. Step one is output mapping. The result of an action, say a flow, retrieves a customer's verified shipping address. That result is mapped securely and automatically to a custom variable. We'll call it verified shipping address.
Okay, so output goes into the variable, verified and secure. Step 2.
Input mapping. That same custom variable, verified shipping address, is then mapped back as the required input for any later actions that need it, like an update shipping record action.
The agent doesn't even have to talk about the address again.
It doesn't. And that's step 3, the profound efficiency gain. By using this mapped variable, you completely remove the need to write these complicated instruction-heavy prompts, trying to force the LLM to remember and pass that address along conversationally.
It's a guaranteed, reliable conduit for data.
100% reliable. The platform handles the data transfer. The LLM just has to focus on the conversation.
That simplifies things hugely. But we still have that non-deterministic behavior to deal with, the
Right.
flexibility that can sometimes break business rules, which is why we need filters, the AI's leash, basically.
That's a great way to put it. Filters are the control layer. They are the mechanism to source the LLM to yield control to the deterministic logic running on the Salesforce platform. They directly counter the LLM's creativity, which, if it's left unchecked, might cause the agent to skip a critical step or violate a policy.
So filters use variable values to create these MFIN statements that decide if a topic or an action is even allowed to run.
And critically, you have to use restraint here. You should only enforce this kind of determinism where it's absolutely necessary. If you lock everything down, you kill the flexibility that makes the agent so powerful in the first place. So what are the 2 mandatory use cases a specialist has to know where you absolutely must use filters?
First one is access control or authorization. This is all about security. Verifying a user's status, like making sure MFA is complete before you execute a high-stakes action. A funds transfer, changing account details, anything like that. Security gates are non-negotiable.
And the second area where the platform has to overrule the LLM.
Hard, non-negotiable business rules. These are fixed constraints that the LLM cannot be allowed to reason around. For example, a rule that a specific discount can only be applied if an order value is over a fixed dollar amount. The platform has to enforce that, not the LLM.
This all culminates in what you call the invariant rule, the central idea. Agents plan, but the platform executes. This is the rule of law for Agentforce. Any state-changing action, any authoritative data retrieval, must invoke an existing flow or an idempotent apex action. This guarantees that all your built-in platform security, your FLS, your validation rules, is enforced on every single action. The AI can't bypass your existing business logic.
All right, let's shift gears. We're moving from that rigid structure into the domain with the absolute highest weight on the exam: prompt engineering, templates, and grounding. This is a massive 30% of your total score.
It is the core user-facing layer. The prompt is really the only direct lever a specialist has to shape the AI's output, to make it secure, connected to CRM, and compliant with your brand's voice.
And we use the prompt builder for this, which combines 3 key pieces: ingredients, which are your data merge fields, guidelines, the instructions, and tone, and grounding, the trusted data.
Exactly.
Now let's talk about the template lifecycle. A template has to be explicitly activated to be used. This is a step people miss, right? If you just save it as a draft, it's invisible.
Oh, it's a common mistake in sandboxes. And related to that, how do you measure if a prompt is even working well in production? The primary metric is frequent agent editing.
Meaning the human is constantly rewriting what the AI suggests.
Exactly. If your support agents are spending half their time correcting the AI's draft, your prompt has fundamentally failed. It's creating more work, not less.
Okay, let's get into the 3 key template types and their critical constraints. First up, field generation.
Field generation templates are designed for one specific job: populating text for a single field. A great example is summarizing 50 pages of case notes into the short description field.
And there are 2 mandatory constraints here. One is user interaction.
Right. It requires mandatory user interaction. The human in the loop has to physically click the little Einstein generate icon that appears next to the field.
And 2, there's a technical dependency on the Lightning page itself that is so easy to forget.
Absolutely critical for the exam. The Lightning page must use dynamic forms. This technical dependency is there because dynamic forms are what allow you to place that specific Einstein button right at the field level in the UI. No dynamic forms, no button, no functionality.
Okay, next up, sales email templates.
These are pretty straightforward. They're specifically for drafting sales outreach in the email composer. They're launched from a dedicated button that's labeled Draft with Einstein. It's a specialized tool for that one interface.
And finally, the heavy lifter, The Flex template. This one's for complex data
The
synthesis.
Flex template is required for your most advanced use cases, specifically multi-object data synthesis. This means pulling data from, totally unrelated objects to generate one comprehensive output.
And because it's so complex, it has a special execution requirement.
It does. It must be executed programmatically. You can't just click a button to run a Flex template.
No button click.
No button. It has to be called as an invocable action from a flow, from Apex, or from an API. This ensures all that complex data gathering is handled securely by the platform before the prompt is even built.
Okay, so we've got the right container. Now for the instructions inside it. We know prompts have to be unambiguous, but let's dive into the 4 specialized crafting techniques. First, role-playing.
Role-playing is the quickest way to shape the AI's tone and vocabulary. You just tell it its persona. You're an experienced, empathetic, technical support agent. The sources we looked at cited testing that showed a pretty substantial 38% jump in perceived usefulness just by getting the persona right.
Wow. Okay, second, few-shot learning. This is where you provide examples, but there's a tricky data constraint here.
It is tricky. You're trying to teach the LLM the output format you want. The critical constraint is that your examples must closely mimic the dynamic input structure. So if your live customer ID from a merge field is a 15-digit string,
Your example better have a 15-digit string.
or the model will get confused. The format of the example is just as important as the content.
Okay, third technique, prompt chaining.
This is all about modularity. You break a complex goal like summarize a complaint, identify the cause, then draft a reply into a sequence of smaller, focused prompts. It makes debugging so much easier because you can see exactly which step in the chain failed.
And finally, chain of thought, or COT. This is where you make the AI show its work.
COT is crucial for anything that requires complex reasoning. You explicitly tell the model, think step by step before giving the final answer. It forces a structured analytical process.
And it really works.
It really works. The data point cited was a 46% accuracy jump in complex debugging use cases, just from forcing the model to walk through the problem logically first.
Okay, let's talk about connecting these prompts to real data. We know record snapshot grounding is a quick way to grab data from a page layout, but what's the critical thing it excludes?
The critical constraint to memorize is that record snapshot grounding specifically excludes activities, tasks, and events.
Why is that?
It's likely a performance choice, since those objects can have huge data volumes. But the bottom line is, if your prompt needs data from a customer's recent tasks, you must use a merge field or a flow, not the simple snapshot.
And if we need to ground our prompt in that unified data from Data Cloud, you can't use a merge field for that.
Correct. Accessing those unified data model objects, the DMOs, requires a specific architectural pattern. You need a template-triggered prompt flow. The flow goes and fetches the unified data from Data Cloud, and then it securely passes that information to the template before it gets sent to the LLM.
Okay, last thing in this section. The specialist has to know the 3 key permission sets for prompts?
Yep. First, Prompt Template Manager. That's the builder role. They can create, edit, and most importantly, activate templates.
Okay.
Second, Prompt Template User. That's the end user. They need this to actually see and run the active templates. No permission, no button.
Simple enough.
And third, Einstein Sales Emails. This is a specific permission just to use the sales email template type from that Draft with Einstein button.
All right, let's shift to the data foundation itself, which carries a solid 20% of the exam weight. This is all about making sure the agent's knowledge is clean, unified, and trustworthy. And that means mastering Data Cloud.
Absolutely. Before the AI can use any of this knowledge, the data has to be ready. This starts with what we call data flow mastery, the sequential journey data takes inside Data Cloud.
So this journey has 3 crucial sequential stops: DSO, DLO, and DMO. What is the data source object, the DSO?
The DSO is the initial raw landing spot. Think of it as the loading dock where the data first arrives from another system. It sits there in its original format, reflecting the source system's schema. It's completely untouched.
Then it moves to the data lake object, the DLO, for refinement.
The DLO is the staging ground. This is where the data gets mapped, transformed, prepared. All the ETL processes run here to get it aligned to the broader data model.
And the final destination is the data model object, the DMO. And this is where there's a critical distinction that trips people up on the exam.
This is a classic trap. The DMO does not store the data itself.
So it's empty.
No, it acts as a standardized logical layer. It's a structured view, like a standard Salesforce object with defined fields and relationships. When you query the DMO, the data is dynamically referenced from the underlying DLO and DSO layers.
So it's just a pointer, a view that ensures the data is always fresh.
That's the perfect way to think of it. It's a standardized endpoint for the agent's data requests, not a massive redundant data store.
Okay, once that foundation is stable, we use RAG to ground the LLM in that enterprise data. And this starts with creating a data library, which automates a lot of complex steps.
Right. The whole point of RAG is to maximize accuracy and build trust. When you create a data library, Salesforce automatically handles 4 critical RAG preparation steps in the background, and you need to know them sequentially.
Okay, walk us through the 4 automated steps.
1. Loading. That's just getting the raw, unstructured text or knowledge articles, your policy docs, into Data Cloud. 2. Chunking. This is essential. It breaks down those long documents into smaller, manageable segments.
Because the search tool can't handle a 100-page document all at once.
Exactly. Then step 3, vectorization. This is the magic part. It converts those text chunks into numerical embeddings or vectors.
And that's what enables semantic search, meaning based matching, not just keyword matching.
Right. And finally 4, storing. All those process vectors are managed in a specialized vector database, which is optimized for these super fast semantic lookups.
Now, there's a huge constraint on the data library that's vital for governance.
Yes. You can have only 1 data library per AI feature instance.
Per agent.
1 per agent, 1 per feature. This forces careful curation of your knowledge sources. And of course, the user setting this all up needs the powerful Data Cloud admin permission set.
And creating that library automatically creates 3 other essential components, right?
Correct. It auto-creates a data stream for ingestion, a search index to organize the vectors, and a retriever, which is the tool that actually fetches the data.
Okay, so when the agent needs knowledge, it searches that index. We have 3 search types to choose from. Let's start with vector search.
Vector search is semantic. It matches meaning and intent. It's perfect for unstructured data case notes, email threads, dense policy docs, where the exact phrasing can vary, but the meaning is what you're after.
Then there's the old school approach, keyword search.
Keyword search is lexical. It matches exact terms. It's ideal for highly structured data products, SKUs, error codes, specific document titles, where you need that precision.
And the modern default is hybrid search.
Hybrid search is the gold standard because it combines both. It runs a vector and a keyword search and then intelligently blends the results. It gives you the best of both worlds, really.
Okay, and the tools that perform the search are the retrievers. There are 3 types here, too.
Yes. You have the default retriever, which is auto-created. It's simple, but it's non-customizable. Then you have the custom retriever. This one is flexible, developer-built, and it supports versioning for governance and testing.
But there's a constraint on that versioning.
Right. Even though you can have multiple versions, only one version can be active at any time. And the third type is the dynamic retriever.
What makes it dynamic?
It's used as a smart placeholder in a template. Its configuration, what it's actually searching for, is defined at runtime based on the immediate context, like the merge fields from the record the agent is looking at. It adapts on the fly.
We're moving into the operational rigor now, deployment and metadata mastery. This is the unsung hero of enterprise AI because deploying these things is not a simple metadata push.
Oh, if your deployment process is messy, your AI will be unreliable. That is a guarantee. You have to treat these agents like sophisticated software products that require full CI/CD rigor.
The sources outline 6 essential steps for a successful rollout. Let's start with number 1, plan.
The key part of the plan step, beyond stakeholder alignment, is the data readiness review. This means making sure your data cloud models are clean and governed before you build a single prompt. Building an AI on bad data is just a recipe for disaster.
Step 2, metadata mastery.
This is just knowing your stuff. You have to grasp the specialized metadata types, gen templates, gen functions, gen planner bundles, and their strict dependency structure. This alone prevents most deployment failures.
Step 3, automate.
You have to use CI/CD pipelines, Gearset, Capado, whatever your tool is, to enforce the correct deployment order automatically. It just reduces human error.
Step 4 is test, and this is more than just unit tests.
Way more. This is specialized user acceptance testing, UAT, to validate the AI's output. Is it accurate? Is the tone right? Are the safety guardrails working? You have to prove it's safe, not just that it runs.
And the last 2, version control and observability.
Version control gives you a single source of truth and auditable rollbacks. Observability is your feedback loop monitoring agent metrics like resolution rates and feeding that data back into the next refinement cycle.
Okay, this is the high-stakes section, the metadata hierarchy. If you deploy these things out of order, the deployment just fails instantly.
It's a hard fail. The core principle is simple. Dependencies have to exist before they are referenced.
So step 1 in the sequence.
Auxiliary artifacts. This is all your prerequisites. Flows, Apex classes, custom fields, custom metadata. If an action needs a flow, that flow has to be there first.
Makes sense. Step 2.
.bot version, the top-level agent container itself.
Step 3.
Gen template. The prompts, they have to be in place before the functions that call them.
Step 4.
Gen function, the actions. This is a critical checkpoint.
Right.
The deployment will fail here if it can't find the templates or flows it references.
Step 5.
Gen plugin. These are the topics, the logical groupings of functions. You deploy them after the functions they contain are already in the org.
And the final step, the one that causes the most trouble.
The final step, number 6. The Gen planner bundle. The orchestrator. The brain. This is the most common failure point in a production deployment.
Why is the planner bundle such a bottleneck?
Because it's the top of the pyramid. It depends on everything else being perfect.
Right.
It will fail if any reference, plugin, function, or template isn't already active and resolved in the target org. You're trying to deploy the brain before the nervous system is connected. It just doesn't work.
So if I mix up the order, I'm guaranteed to fail and have to start over.
Guaranteed failure. And you also have to remember the target org prerequisites. You need the right API version, licensing has to be provisioned, and you have to manually flip all those Einstein feature toggles in setup before you run the deployment.
Let's bring this home with a focus on security and external access. We have to make sure that when these agents talk to the outside world, the Salesforce trust layer is keeping things safe.
The Einstein Trust Layer, or ETL, provides these crucial safeguards when you're communicating with an external LLM, which is operating outside your corporate trust boundary.
What are the 2 key functions of the ETL? Let's start with data masking.
Data masking is vital. It identifies and masks sensitive data PII, credit card numbers, before it leaves the Salesforce trust boundary to go to the LLM.
So the external model never sees the real data.
Never. The demasking happens on the way back inside Salesforce, before the response is shown to the user.
Okay, and the second function is toxicity scoring.
The ETL is constantly monitoring for harmful, biased, or inappropriate content in the AI's responses. It generates a toxicity score, which lets you flag or even block problematic outputs before they ever reach a customer. It's your brand safety net.
Okay, now let's talk about connecting to these agents from an external app, using the agent API. What's the fundamental constraint on which agents you can even use?
The critical constraint here is that the agent API is not supported for agents of type Agentforce default. You must use a custom agent type if you want to integrate via API.
And access requires a connected app. You need 4 specific OAuth scopes for the access token to work. What are they?
You need 4.chatbot, which is for the agent services.cp, for the automation platform.ap, for general platform access. And then refresh token or offline access to make sure the session stays alive.
Okay, so if I'm a developer trying to start a session, I need 4 critical pieces of info for that API call.
It's a strict checklist. You need the agent ID, that 18-character Salesforce ID. You need the access token from your connected app. You need a random UID, which is crucial for tracing and logging. And you need the My Domain URL.
Not the generic one.
Not the generic one. It has to be your specific, your company domain, .my.salesforce.com URL, or the call will fail.
Finally, let's clarify the security context. The bypass user parameter, what does that do?
That controls whose permissions the agent operates under. If you set bypass user to true, which is standard for a machine-to-machine flow, the agent uses the agent owner's permissions. It runs with the FLS and object access of whoever set the agent up.
And this is all enforced by the hosted MCP servers.
Yes. The multi-cloud processing servers execute all the platform actions in the security context of a specific authorized Salesforce user. This is what guarantees that FLS and all your other object permissions are enforced. The AI can't just bypass your security architecture.
We have just completed a really comprehensive technical deep dive here, focusing relentlessly on those architectural constraints you need for the certification. We hit the 4 agentic capabilities, the absolute critical constraint that custom variables only get set by action outputs, the 30% weight of prompt engineering.
With those dynamic forms and programmatic flex template requirements.
Right. Then the data cloud flow from DSO to DMO, the strict 6-step metadata deployment order, and the security enforced by the ETL and those 4 API scopes.
The central theme, really, that unites all of this is that tension between the flexibility of generative AI and the predictability you need in an enterprise. The success of Agentforce really comes down to the architectural bridge provided by variables and filters.
They're the components that transform the chaos into structure.
They transform the powerful but chaotic flexibility of AI into the rigid, secure, deterministic business processes that run on the Salesforce platform. That's the governance model.
It's a complete system of governance. And we established that the hosted servers enforce that security by running actions in the context of a specific user.
But here's the final provocative thought for you to chew on. We know that these automated actions often run under the identity of a single shared integration user account, which is usually highly privileged.
Right, for efficiency.
So imagine you have multiple distinct autonomous AI agents, one for payments, one for data updates, one for support, all operating concurrently, making high-stakes decisions, but they're all operating under the security umbrella of that one single high-privilege integration user identity. What new governance challenges does that introduce? How do you apply fine-grained restrictions or create an audit trail per agent when they're all sharing a single identity? It suggests the governance work doesn't stop once you pass the exam.
That is a fascinating challenge that goes way beyond the exam and into real-world identity management. Thank you for joining us for this crucial deep dive. Go master that material.